could you be the one? Shh. Good, could you be the one?
So let's have a review today, grade 10 students, in preparation for your exam tomorrow. So for example, we have this question in polynomial function. And the common question is, we are going to write the polynomial function in standard form. Let's say we have this question. Question number 1. Write a polynomial function in standard form. Which has zeros, positive 2, negative 1, and 3. So all real numbers. Now, first solution is you are going to write this as x equals 2, x equals negative 1, and then x equals positive 3. So those are the zeros, so meaning that those are the that will be your solutions. So that is the reason why I put x equals 2, x equals negative 1, and x equals 3. Then you're going to transpose this. Okay, so it will become now x minus 2 times x plus 1 times x minus 3. So once you transpose, you are going to change the sign. If it is positive, make it negative. Negative will make it, write it positive. Then positive 3, make it negative 3. Okay? Then equated to 0 equals 0. And then multiply this binomial. So we have now x times x equals x squared. We added exponent. Then x times 1, we have 1x or x. Then negative 2 times x, we have negative 2x. Then negative 2 times negative 1 equals negative 2. So we have this answer there, times x minus 3 equals 0. Okay? And then we have now combined similar terms. X minus 2x will become x squared minus x minus 2, and then times x minus 3 equals 0. And then multiply this trinomial to x minus 3. So it will become now x times x squared equals x cubed. X times negative x equals negative x squared. Then x times negative 2 equals negative 2x. Then after that, multiply this also. The negative 3. Negative 3 times x squared equals negative 3x squared. Then negative 3 times negative x equals negative 3x. Then negative 3 times negative 2 equals positive 6. By the way, here negative 3 times negative x equals positive 3x. Then get the sum. We have now bring down x cubed. So we have negative 4x squared plus x plus 6. So since the question is about polynomial in standard form, you are going to use the symbol of polynomial. So we can use p of x here equals. So this is now the answer. Or you can use other symbol of polynomial function. We have h of x, f of x, g of x. So it's up to you. Okay? So that is question number 1. Another problem about polynomial function, especially writing it in standard form, if there's a given zeros which are imaginary number. For example, question number 2. Write the polynomial function in standard form with the following zeros. Negative 4i, positive 4i, and 2. So if there's an imaginary number involved, so all you have to do is the same process. So write first these zeros as x equals negative 4i, and then x equals positive 4i, and the last one is x equals 2. Okay, so we are going to transpose this. So we have now x plus 4i times x minus 4i times x minus 2 equals 0. So we are going to equate again to 0. And then multiplying this binomial, x plus 4i times x minus 4i. So x times x is equals to x squared. X times negative 4i equals negative 4i x. Then 4i times x equals positive 4ix. Then 4i times negative 4i equals negative 16i squared. So this is the answer. Then multiply to x minus 2 equals 0. So combine singular terms. So since this term have different sign, so we can cancel it. The result will become 0. So we have now x squared minus 16i squared. Then times x minus 2 equals 0. But since we have I squared, remember I raised to the second power. So I raised to the second power equals negative 1. So that is the value. So change this to negative 1. Negative 1 times negative 16, it will become now x squared plus 16 times x minus 2 equals 0. So multiply x squared times x equals x cubed. Then x squared times negative 2 equals negative 2x squared. 16 times x equals 16x. Then 16 times negative 2 equals negative 32 equals 0. Then going back to the question, you are going to write this polynomial function in standard form. Since we equated this to 0, so we can use now p of x is equals to x cubed minus 2x squared plus 16x minus 32. So this will be your final answer. So when you say standard form, just look at the exponent if it is arranged in descending order. Okay, descending power of exponent. So 3, 2, 1, and the constant. Let's proceed now to question number 3 of our review. So this is about a remainder theorem. If we are going to divide a polynomial, let's have this question. Question number 3. So what is the remainder of quantity x cubed plus 2x squared minus 4x plus 5 divided by x plus 3? So this is the question. Now, since we already introduced the remainder theorem, so we can apply here instead of using synthetic division or using the long division method. So we can use now remainder theorem. How? So in using the remainder theorem, we are going to solve x plus 3, the binomial, equate this to 0, solving for the value of x. So we have now x plus 3 equals 0. Then transpose this, so x is equals to negative 3. Then using the remainder theorem, we will use now the p of negative 3 is equals to x cubed plus 2x squared minus 4x plus 5. Then since we have negative 3 here, so we are going to substitute now negative 3 raised to 3 plus 2 times negative 3 squared minus 4 times negative 3 plus 5. So negative 3 raised to the third power, so it means we will multiply negative 3 times. So the result is negative 27. Then plus negative 3 squared is 9, 9 times 2 is 18. And then negative 3 times negative 4 is equals to positive 12, then plus 5. Then simplifying this, negative 27, then plus 18 equals negative 9. Okay, then plus 12 plus 5. Then again negative 9 plus 12 is equals to positive 3. Then plus 5 is equals to 8. So P of negative 3 is equals to 8. So since we have the answer 8, so this will serve as your remainder. So this is your remainder using the remainder theorem. So what is the remainder of x cubed plus 2x squared minus 4x plus 5 divided by x plus 3? So the answer is equals to 8. So the answer is 8. Okay guys? So no need to use the synthetic division or the long division method. So all you have to do is apply or use the remainder theorem. Okay, our next question is, we are going to determine the possible combination of positive and the negative zeros of the given polynomial function using the Descartes rule of signs. This is the example, guys. P of x is equals to 4x raised to 4 minus 3x cubed plus 2x squared plus x minus 5. If this is the given polynomial, if this is the given polynomial, so we are going to determine the possible combination of positive and the negative zeros. So first thing to do is we will solve this using P of x. So determining the sign of each term. We have positive, we have negative, positive, positive, negative. So we will find first the variation, number of variations. So we have 1, 2, 3. So we have here 3 positive variations. So when we say variations, that is the alternating in signs of each term. So we have positive, negative, negative, positive, and positive, negative. So the number of positive variations is equals to the number of the positive zeros. And then to find the negative variations, we will use this P of negative x is equals to 4 times negative x raised to 4 minus 3 times negative x raised to 3 plus 2 times negative x raised to 2 plus negative x minus 5. Then simplify. So if the exponent is uneven, so the answer will be retained. The same, 4x raised to 4. Exponent is odd number, so change the sign, so it will become now plus 3x cubed. So I'm referring to this. Then even, so it's still the same, positive 2x squared. Then add, so we have now minus x minus 5. So to determine the variations, we have 1. So we have here 1 negative variations. So 1 negative variation. Now, after computing this, we are going to construct a table of values. So it's divided into 4 columns. So the first one, we have the positive zeros. Then we have the negative zeros. We have the imaginary zeros. And of course the total. We will include the total here. Okay? So in the first answer, we have 3 positive variations. So just write here 3. Then negative zeros is equal to the negative variation, so we have 1. So the total, we will use the degree, the highest degree. So 4. So imaginary zeros will become 0. Why? Because 3 plus 1 is 4. 4 minus 4 equals 0. So since if we are going to observe in the positive zeros, we have 3. So it's still divisible by 2. So we can subtract it by 2. So 3 minus 2 is equals to 1. Then in the negative, just copy, just retain the same. Then here, total is 4. 1 plus 1 is equals to 2. Then 4 minus 2 is equals to 2. So the possible combinations of positive and negative zeros, we have 3, 1, 0. So 3 positive zeros, 1 negative zeros, 0 imaginary. And another is, it's either 1 positive zeros, 1 negative, and the other solutions will be 2 imaginary zeros. So this will be your answer now, using the Descartes rules of science. Okay, thank you.